All right, folks, we've got section 15.8 that we have to do, which is talking about cosecant, secant, and cotangent functions. These are the other three remaining trig functions that we are going to be dealing with for the rest of the year. So let's define them. Let's go back to our reference triangle that's in the very first quadrant here. When we draw in our right triangle, we know that this side is going to be x, this side will be labeled as y, and then your ray or radius is your hypotenuse, that's going to be labeled r. So what you have to understand is that the secant, cosecant, and cotangent functions are simply the reciprocal of your sine, cosine, and tangent functions. So we just have to make sure that we know which one goes with which. So let's start off with cosecant. Cosecant, which is abbreviated with the CSC, is the reciprocal of your sine. So cosecant theta is the same as 1 over sine of theta. So if you think about what the definition of sine was, opposite over hypotenuse or y over r, if we're going to do the reciprocal, now that's going to be r over y, or hypotenuse over opposite. The next one is secant, which is abbreviated with SEC. So secant theta is the reciprocal of cosine, so 1 over cosine theta. And if you remember, cosine was adjacent over hypotenuse, or x over r. And so if we're going to do the reciprocal of that, now we're going to do r over x, or hypotenuse over adjacent. And then cotangent, I bet you couldn't guess that, was the reciprocal of tangent. So 1 over tangent, or since tangent is opposite over adjacent, now we are adjacent over opposite, which is x over y. So what you're going to have to do is, it's fairly simple to remember that cotangent and tangent relate to each other, but trying to keep track of the fact that secant is the reciprocal of cosine and cosecant is the reciprocal of sine. Because a lot of people think that cosecant would go with sine, or go with cosine, and that secant would go with sine. So just remember that they're switched. Okay, so that's going to be a hard thing to keep track of. So the nice thing is, most of the problems that you've seen already, we're going to repeat here, only looking for the new 3 trig functions. So for example, I give you a point P, and I want to have the ray pass through that point, and then I want to find cosecant, secant, and cotangent of the theta that's created by that ray. So if we look at this one, where P is -5, -3, that's going to put us down here in the third quadrant, and we can fill in the values of -5 and -3, and do a little math with the Pythagorean theorem, and we get that the hypotenuse, or the radius, is the square root of 34. So remember, if you recall, this right here is theta, but we're using our little reference angle, this angle right here, to calculate it. Okay, so let's first start with cosecant. Cosecant was the reciprocal of sine. So if we look at our triangle, sine was opposite over hypotenuse, so now we're doing hypotenuse over opposite. So -√34 over 3, which is nice, we don't have to rationalize. Okay, next one is secant. So secant is the reciprocal of cosine. So cosine would have been -5 over √34, so now we're -√34 over 5. And then cotangent, which would have been 3 over 5, is now 5 over 3. So not too bad, okay? If you recall, there was another type of question that we did where they give you a trig equation here, and you have to figure out what theta is, or you don't have to figure out what theta is, I'm sorry. Thinking of a different section altogether. We are going to use this equation to build our reference triangle, and then find the other 5 trig functions, because they've already given us 1. They gave us the cosine. So we're in quadrant 2, told us, okay? Using the 1 and the 3 and the negative, we can place those where they go. Use Pythagorean theorem and figure out the remaining side. And so what I like to do is figure out the original 3 first, because then all I have to do is take the reciprocal to find the new 3. So we already have cosine, so let's figure out what sine is. Sine is going to be opposite over hypotenuse. We already have cosine. And then tangent is opposite over adjacent. So we didn't really need this 1 here, but I put it here so that when we do cotangent, we remember that there's a 1 down there. Okay, so now let's go through and do the new 3, starting with the reciprocal of sine, which is going to be cosecant. So cosecant, the reciprocal, ends up giving us a radical in the denominator. So then we have to rationalize, and we get 3 root 2 over 4. Okay, and then we can do cotangent. Okay, so we're doing the reciprocal of this, so that gets us a negative 1 over 2 root 2. And so now we have to rationalize, and we get negative root 2 over 4. Okay, and then the last one, which is secant, is just the reciprocal of this that they already gave us, so that's just going to be negative 3. Okay, so that is your basic type of triangle questions that you're going to have to do with secant, cosecant, and cotangent. But now what we're going to do is some calculator work. All right, so on your calculator, you only have sine, cosine, and tangent. We don't have cosecant, secant, and cotangent buttons, unfortunately. So we have to be a little creative in the way that we use our calculator. So if you recall, cosecant is the reciprocal of sine. So I can actually rewrite this expression as 1 over the sine of that angle, 123 degrees, 40 minutes. And you should have a reciprocal button on your calculator, which is going to look like 1 over x. That should be a button, or maybe it's x raised to the negative 1. So take a look at your calculator and see if you have that button. Because what you're going to do is you're going to go through, just like we did before, and evaluate the sine of 123 degrees, 40 minutes by figuring out the decimal, calculate this out. We get this decimal, this is the sine of 123.66666, blah, blah, blah. Okay, but we want the reciprocal of that. We want 1 over that. So keeping this decimal in your calculator that you just evaluated, find this button on your calculator and hit it. And when you do, you get the answer. Okay, so that came out to be 1.2015. Okay, so these, remember, are the easy ones. It's when we have to do the inverse that it gets complicated. So let's take a look at how to do the inverse for cosecant or secant or cotangent. So I'll get rid of this. Don't need that anymore. Okay, so in this example, we're doing the secant of theta is 1.131. We need to solve for theta, and we want theta to be between 0 and 360 degrees. So that means all 4 quadrants are potentially used. We're going to use 2 of them, and therefore get 2 answers. All right, so first step. Remember that secant is the reciprocal of cosine. So if I wanted to, I could rewrite this equation as the cosine of theta instead of secant, but then I take the reciprocal of this number, so 1 over 1.131. And now I have an equation where I can actually use my calculator because I have that inverse cosine button. But the first thing you're going to have to do is actually figure out what this is as a decimal. So take 1 and divide it by 1.131, or type in 1.131 and then hit your reciprocal button, and you end up getting the cosine of theta is 0.88417. And so now we want to do the inverse. So we're going to do cosine inverse of that decimal, and we get 27.85004. And then we strip off the 27 to figure out how many minutes this is, multiply that by 60, and we get 51 minutes. So that means that our first angle that we get is 27 degrees, 51 minutes. All right, so here's another thing that you should know. With all students take calculus, the same relationship holds for secant, cosecant, and cotangent. So if you have the quadrant where sine is positive, that's also the quadrant where cosecant is positive, since cosecant is simply the reciprocal. We didn't change the plus or minus of it, we just flipped the fraction. Okay, so when we look at this and we're talking about cosecant, we're really dealing with cosine. Which quadrant is cosine positive in? Well, the first quadrant, obviously, and then the fourth quadrant. So if we sketch out a little diagram here, we know that this angle that we just solved for goes right here. It's in the first quadrant. But we also know as a reference angle, it's going to be congruent down here. So both of those are 27 degrees, 51 minutes. Now, the second angle that we are looking for is this one that goes all the way around. Oops, went a little too far, but you get the idea. It's the one that goes all the way around is in the third quadrant. Okay, so to figure that one out, we're going to take 360 and then subtract the 27 degrees, 51 minutes. And if you forgot how to do that using the borrowing a degree and turning it into minutes, this turns into 359 degrees, 60 minutes. Line up your degrees and minutes and just subtract. So we get 332 degrees and 9 minutes. And that is your second answer. Okay, so there you have it. A lot of familiar stuff from before, but just dealing with our reciprocal trig functions. Okay, that's all, folks.